You've probably seen this happen. Two people, both smart, both using the exact same AI tool. One of them gets a precise, incredibly useful output, the other gets something generic, kind of useless. The difference isn't their vocabulary, it's their architecture. And this right here is the core idea we're going to unpack. An AI isn't really misunderstanding your request. What it's actually doing is faithfully, literally executing the instructions that are embedded in the design of your prompt. This isn't about semantics, it's about systems. So the big question is why? Why does a structured request, one with clear, distinct sections, so dramatically outperform just a simple paragraph of text? This isn't some random quirk. It's a fundamental principle of how these models actually think. And what's really fascinating is that this pattern shows up everywhere, no matter what you're trying to do. It's a universal principle of our interaction with AI. So let's just watch it play out in a few different contexts. Okay, take a coding task. The unstructured prompt on the left is just a block of text, right? It forces the model to guess at what's most important. But the structured version on the right, it separates the context, the function, and the constraints. See, you're not just organizing it to be neat, you're explicitly telling the model how to weigh each piece of information. And we see the exact same principle with a research task. An unstructured query, well, it's like a fishing expedition. You cast a wide net and hope for the best. The structured prompt, though, it isolates the variables. It defines the core question. It tells the AI which sources to consider, and it sets the output format. You're turning a vague wish into a defined protocol, which completely focuses the model's ability to synthesize information. Even in creative work, the rule holds. Just throwing a blob of text at the model to generate content, it often just misses the mark completely. But when you give it a scaffold, a defined persona, key messages, a specific tone, you're not stifling its creativity. You're guiding it. You're making sure it stays aligned with what you actually want. All right, so we've seen the pattern. Now let's go a level deeper, from just observing to actually analyzing. Why does this work on a systems level? It turns out there are three core mechanisms that really explain the power of prompt structure. The first one is called entropy reduction. The easiest way to think about it is like this. A language model is always predicting the next word from this huge, vast field of possibilities. An unstructured prompt is a wide open field with countless paths it could take. A structured prompt, on the other hand, mathematically shrinks that field before the model even starts generating. You're not just being clear, you're fundamentally making the model's job simpler. But this is where it gets interesting. This mechanism introduces a really critical trade-off. See, tightly structured prompts are absolutely perfect for analytical tasks where you're converging on one right answer. But for creative, divergent tasks, too much structure can actually kill off the useful, interesting variations. The real skill is learning how to modulate that structure, knowing when to tighten the constraints and when to loosen the scaffold. The second mechanism is that rules act as local objective functions. Basically, when you list out explicit rules like do not exceed 500 words, use a formal tone, avoid jargon, you are transforming your prompt from a simple request into a constrained optimization problem. And that's a format the model is specifically fine-tuned to solve. And here again, there's a trade-off. While rules definitely increase the alignment of the output, they can also make it feel brittle or rigid. This is why the most skilled users don't write scripts. They design boundaries. They define what not to do, which gives the model a clear framework to operate in while still preserving its flexibility. And the third and final mechanism is attention weighting. It's simple but powerful. What you put first in your prompt sets the frame for the entire generation. What you put last heavily biases what it says next. Using lists, headings, and separators isn't just for you to read it better. It's how you literally architect the model's focus. Now, this means you can get a completely different output simply by reordering the exact same information. The takeaway here is pretty profound. The difference in an AI's output is often not about what you said, but about the architecture of how you said it. So, what's the cost of ignoring all this? Well, you get what I call engineered ambiguity. By failing to structure our intent, we end up unintentionally sabotaging our own results. In the real world, this looks like professionals just stuck in these endless cycles of refining vague outputs. It's developers blaming the model for bugs that were actually caused by ambiguous instructions. It's creators getting frustrated with inconsistent tone, and analysts trusting a synthesis that sounds confident but is actually really shallow. The cost is time, it's quality, and ultimately, it's trust in the tool. And all of this brings us to a really critical realization. Failure when you're working with AI is rarely some single big catastrophic event. It's the slow, steady accumulation of instructional misalignment. It's a series of small ambiguities that cascade into a total failure. So, what's the edge? How do expert users consistently get what they want? Well, they don't just write prompts, they architect their intent before they even type a single word. Their internal workflow looks something like this. First, they define the core intent. What is the single most important outcome? Second, they architect the information hierarchy. Third, they design those explicit constraints, the boundaries we talked about. Fourth, and this one is so important, they separate exploration from execution. They play around first, then get serious. And fifth, they always build a verification loop. They never, ever trust the first output as the final answer. Look, this isn't about finding some perfect copy-paste template. It's about shifting your mindset from being a writer to being a designer. So I'll leave you with 3 questions to think about in your own process. First one, how is your prompt built? Is it just a stream of consciousness, or is it a deliberate structure with a clear hierarchy of information? Second, what rules did you give it? Are there explicit constraints of boundaries in there, or are you just leaving it all up to the model's interpretation? And finally, the most important one, what did you design? Because at the end of the day, the quality of the output isn't a reflection of the model's intelligence, but of the clarity of the system you designed for it to execute.